second grade. I hope you're having a great day. We are super excited to start something new in math today. Might not be new to you. Part of it isn't new to you, but some of it will be. So we are going to get our targets ready first, and we are going to read this learning target for ourselves. So get those targets ready. Pull it back. Well, let's read this together. I can use the make a 10 strategy to solve problems. Let's say that one more time. What's the target? I can use the make a 10 strategy to solve problems. Solve addition and subtraction problems. But what does that mean? Well, remember, a strategy is something that we use to help us solve something. It's a way we go about it. It's kind of like a trip on a map, right? So we take lots of different routes when we're going somewhere, and those strategies are different routes of solving addition and subtraction problems. And one of those routes that we're going to be talking about today is the make a 10. So this is where we really and truly make a 10. So remember, a strategy is something that we use to help us get to solving a problem. And the make a 10 strategy is one of those that we're going to learn and spend a lot of time with in second grade. And we're solving addition and subtraction problems. So I'm going to put a plus and a minus here because we're going to see both of those problems today. Before we do that, in first grade, you did a ton of making 10. Let's take a minute and brainstorm. And I know you guys all have your cubes out there. If you need them, you don't have to use them. But if you need them to do this, you're welcome to use that tool. What are some ways to make 10? I'm just going to give you about 1 minute or so to think about some ways, and you might even jot them down in your journals. But when you have some that you're ready to share, I want you to put a thumb in front of your chest so that you can show me that you're ready to share. What are just a few ways to make a 10? See some thumbs? What you got? Well, 10 and 0. That's a good one. What else? 9 and 1. 7 and 3. 6 and 4. 8 and 2. 5 plus 5, yes. I feel like we know that one pretty well, don't we? What about some others? Yeah. Uh-huh. Mm-hmm. Awesome. Holy guacamole. When we work together, we can really get those, can't we? I think you guys have done a nice job with those this so far this year. Are there any others that we're missing? How do you know? 10's the biggest, and the smallest. 10. No. All right. So we're going to keep this up in our rooms just as a little reminder as we're starting to get used to using this strategy. But I have a feeling it's not going to be one that we're going to have to hold on to for very long. Today, we're going to try to use this strategy and these 10 combinations to help us solve some of these problems. It might be addition and it might be subtraction. Our first one that we're going to be thinking about today says 9 plus 7 equals, we don't know. We have to figure that out. So I want you to take a few moments in your math journals, and I want you to show me how you might solve 9 plus 7. And if you can make a 10, see where we can make a 10 in there, that's even better. But I want you to solve it any way that works best for you. And feel free to use your cubes or your counters if you need to while we're getting started. Okay. Could I have you share what you did? Gotta love those 10 frames. What did you draw first? The 9. And then what? Okay, and you put 7 down here. Then what did you do? I saw you did something different there. Oh, you crossed that little guy off and moved it up here. Why did you move it up here? Because it fills up this 10. And what was left down at the bottom? How did you know that was 6? 5 and 1 more. 6. So what did you do next? 10, 6, 16. So what's going to go up here? Okay. You solved it a little different way. What did you do to solve it? Okay. Okay, what did that look like? Why were you breaking apart your 7? In number talk last week, we broke apart one of those. And why'd you choose 1 and 6? Yes. Because that 9 and that 1 makes a 10. And then what did you need to do next? And what did that equal? And voila. Take a minute. I want you to take some private think time. I want you to look at this. And I want you to look at this. Both of these are the same. They're doing some of the same things, but they look a little bit different. Take a minute, and we're going to have an opportunity for some partner talk. It's going to be a quick little conversation. But I want you to look at these two, and I want you to think, how are they the same? What's one thing that's the same? And one thing that is a little different about these. Just a short little conversation. When you're ready to share with your partner, I do want you to put a thumb in front of your tummy, and then I'll give you a time to turn and talk to them quickly. Okay, go ahead and turn and face your partner. Awesome. If you are my A partner, I want you just to share first. You can either share something that is the same about these two ways of solving, or you may share something that is different. Now, B partner, you're going to listen carefully, and then you'll have a chance to share when they're done. Go ahead, A's. And go ahead and switch. B's, I want you to go ahead and share at this point. Okay. What did you two just share? What did you say that was the same? They both had this. What in their work made them write that? They moved that up and it made a full 10. They decomposed that and they made that a 10. And where is the 6 in this? Where is that over here in this friend's work? Right there, absolutely. How do both of these show making a 10? How do both of those make a 10? Right. So when we take one from that 7 and we add it to that 9, it makes a 10. So we might even say that 9 plus 7 really is the same as 10 plus 6, right? We're just moving, a counter, or we're decomposing and just moving that number around a little bit. Absolutely. And we do that when we are making a 10 with lots of different problems. We're just rearranging them and making them just a little bit easier to solve. Absolutely. Absolutely. There was one other thing I wanted us to think about. Why does it make it easier to solve? Why would you want to make a 10? Because I could very easily start at 9 and count on 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 4, 5, 6, and 7. And I land on 16 and I get my right answer, right? I can do that. That's a great way to solve it. Why would making a 10 be an equation or a strategy that might be even easier? That one you can kind of miscount, absolutely. Knowing our teen numbers. When we know facts already, we can use them to help us solve, and it does help us not to miscount, which can be so easy to do when we start counting on, or especially if we were going to count all, we might miscount a little bit easier. So now I'm really going to give you a humdinger. This little guy has been hanging out here, and you guys did a fantastic job of not paying attention to it, but now I want you to. I want you to take a look at this equation. 14 minus 6 equals blank. How would we solve this? We could solve it many different ways. How might we make a 10 to solve it? I want you to take some private think time, use this time to work, and I want you to go ahead and think about what that might look like. Remember, you guys have done a nice job today. We've got to honor that private think time of our friends. And something else we're going to be doing today is really thinking about finding these connections between different strategies or different ways of showing our work. When we make connections, just like we did right here, we're finding how they're the same and how we can see one way and it helps us understand the other way. So we're going to do that with this problem as well. We're really going to keep thinking about those connections that we can make between our friends' ways of solving. This one, 14 minus 6 equals blank. Take a few moments to take some private think time and solve, solve, solve. I'm going to be peeking in and checking in and talking with you. Why did you go that way on the number line? Okay, you made a big jump. Could I have you share that strategy? We're going to have a couple different friends share their thinking. This one was a little bit trickier, right? A bit of a humdinger. So we're going to go ahead and we're going to take a peek at 3 different ways of showing our thinking. Let's go ahead and start. Okay, what did you do first? And how did you show 14? full 10 frame. Okay, and how many extras? And 4. Kind of like this one, a 10 and 6. Okay, and what did you do? Why did you just take away 4? Because it got you to a 10. Okay, well, and then what did you do? Oh, and how many did you have left? How did you know that was 8? 5 and 3. Doing a nice job seeing those numbers in a snap. (14) minus 4 equals 10. Yep. And then 10 take away 2 equals 8. Because you took away the 4. Okay, and then you took away the 2 more. Okay. Let's go ahead and solve a different one. We're going to look and see how these little connections can be made. All right, I want you to talk to us about what you did. What'd you put there? Why'd you put the 14 over there? Because the bigger number, awesome. You're going to be going to bigger numbers or smaller numbers? Why smaller numbers? There's that subtraction sign. Okay, and I noticed that you made a jump that was bigger than 1. You made one big jump. What did you land on when you made that big jump? So how many did you take away? Okay. Then what did you do? Why did you have to take 2 more? I'll write this over here so we can see, we can connect what you're talking. You said you took away 4 and you had to take away 2 more because you still had to go 6. So 5, 6. Want to make sure that everybody can hear what you're saying. So where's your 14 from your equation? And where's your 6 that you took away? 4, 5, 6. And what did you land on? 8. We're going to label that as a big takeaway 6 because your jumps totaled that. Okay, and then an 8 goes here. Interesting. Okay, we got one more we're going to put up here, and then we're going to really think deeply about these 3 ways. Oof. Ooh, okay, here we go. Talk to me. You didn't draw any pictures. So how in the world did you solve this? Okay, what did you do first? Why'd you take away 4? Okay. Then what did you do? And why 2 more? Oh. And what did that get you? Oh. 3 representations. 3 ways of showing. Holy guacamole. How are they the same? Put your thumb in front of your tummy when you can tell me what you notice that's the same about all of them. What was one thing you noticed was the same? Those thumbs went up quick. Start with 14. The answer is 8. Yeah. Where is the takeaway 4 in this one? They crossed it off so that they only had that 10 frame. Where is the takeaway 4 in the number line? The big jump. Where's the takeaway 4 in using the equations? Absolutely. What else is the same? They still had to take away 2 more. There's the 2. There's the 2. There's the 2. Did they all take away 6 from the 14? What number did they decompose? What number did they break apart? They broke apart the 6. Interesting. All of these ways are making 10. We're making 10 to add up here. We're making 10 to subtract down here.